Hey everybody, welcome to mini lecture 10 of week 5, and for today's mini lecture we're going to be focusing specifically on these mass movement deposits. So mass movement or mass wasting literally means any downslope transport of rock, regolith, snow, and ice. When I use the term regolith, we're talking about soil or loose unconsolidated sediment. These mass movements are natural hazards, so they can be very, very dangerous and very destructive. And most people refer to these mass movements as landslides, so you'll often hear that term used. In the photo on the right, this is depicting one of these types of mass movement deposits. So there are different types of mass movement. Today we're going to focus on creeps, slumps, mudflows and lahars, rock slides, and avalanches. Creep, which is just a creepy term, refers to the slow, gradual downslope movement of regolith on a slope. So remember, regolith is soil or loose sediment. This type of mass movement results from a few different processes. It can happen when the ground freezes under super, super cold conditions and then thaws, causing expansion and retraction of the material. This similar process can happen during wetting and drying when there's periodic droughts, and also during really hot temperatures and then followed by a period of cooling. So all of this causes expansion and retraction of the material, and so it will slowly creep down the slope, hence the name creep. When you're looking at the actual area, you can see curved tree trunks here, tilted fences, and also broken retaining walls in certain areas. So there are various features that tell you that creep or mass movement is occurring. The second type is a slump. So here is a slump depicted in the image on the right. And slumps are relatively slow-moving mass movement events during which rock or regolith moves down slope. It stays coherent, so it doesn't disintegrate or lose its shape. So what they refer to this as is a slump block. And slump blocks slide down a specific failure surface. Because it all stays together in one coherent mass, it exposes a head of failure that looks like a steep cliff. So where my cursor is moving right now, that would be what's known as a head scarp, which represents a steep cliff where the movement failed or occurred. Another type of mass movement deposits are mudflows and lahars. A mudflow sounds exactly like what it is, so it's a moving slurry of mud that flows down slope. And that's shown in the top image where we have a mudflow. But mudflows that are specifically made of a mixture of volcanic ash, water, and ice are known as lahars. So lahars are produced from volcanic eruptions, and they're very superheated material because they're interacting with that hot lava, but they're actually the volcanic ash material and water and ice flowing down the slope. Rock slides are next, and rock slides again, the name gives it away. So these are sudden movement of rock and debris down a non-vertical slope, so down some sort of very, very steep cliff face, but not completely vertical. And then it forms a debris pile at the base of the slope. So in this image to the right, this is showing a rock slide, a boulder the size of a small boulder. And then finally we have avalanches, and so avalanches are large drifts of snow and ice, but sometimes can also be made of rock material that rapidly moves down slope where it knocks free additional material. In other words, it's basically a broad slab of snow and ice that detaches from the slope along a frozen surface of failure. So there's some sort of frozen surface that causes fresh new snow to slip off of it. And so these are pictured in the two images on the right. So what exactly causes slope failure? Well, here's a list. So we have shocks, vibrations, and liquefaction, which all result from earthquakes. So earthquakes cause slope failure. Loading, steepness, and support are changes in those things. So for instance, loading refers to if we have an addition of material to a slope, it can cause it to destabilize and fail. say there's some sort of change in the steepness as a result of faulting or some sort of land structure that would also possibly cause slope failure. And then when we refer to support, that could be an underground weakness or some sort of change in the cliff face. Weathering processes also cause slope failure. Vegetation cover can stabilize slopes, reducing slope failure, and then water content, things like rapid storm events, precipitation, and then finally volcanic eruptions. So time to get going and finish your lesson on the Meadville landslide. Thanks for listening today, and as usual, answer all of the associated questions and take your time and read.